student, I am Mr. Praveen Kute. Today we are going to study the 11th science physics 8th, 8th chapter sound. In this chapter or in this lecture we are going to study few points like introduction, types of waves and mathematical expression of the wave. In introduction we must know what is the sound. In physics, sound is a vibration that propagates as an acoustic wave through the transmission medium such as gas, liquid, and solid. In this definition of sound, we have word acoustic wave. What do you mean by wave? This part is given in introduction of this chapter. The wave is a periodic and regular disturbance in a medium which does not cause any flow of material but cause the flow of energy and momentum from one point to another point. In simple words, this definition of wave can be given in another word, that is the oscillatory disturbance traveling through the medium. Oscillatory disturbance traveling through the medium. That means the particle of the medium vibrates at their position about mean position. They does not cause any flow of material. Okay, this is the wave. Now we are going to study the next point, that is the type of waves. There are three types of waves explained in this chapter, that are the mechanical waves, electromagnetic waves, and the matter waves. In mechanical waves, wave is said to be mechanical if material medium is essential for its propagation. If material medium is essential or needed for the propagation of wave, such waves are the mechanical waves. For example, water waves, waves along straight string, sound waves, these are the mechanical waves which require material medium for the propagation. Water waves is the common example. Wave along the straight string is also common example. So these are the mechanical waves. Then the second type, that is electromagnetic waves. What is the electromagnetic waves? These are the waves generated due to periodic vibration in electric and magnetic fields. They are propagating through space. However, material medium is not essential for their propagation. That means electromagnetic wave can pass through space also. What are the examples of the electromagnetic waves? The example given for the electromagnetic waves are the radio waves, microwaves, ultraviolet rays, X-rays, gamma rays, etc. These are the few examples of electromagnetic waves given in the book. So then we are going to third point, that is the matter waves. Matter waves, there are always a wave associated with any object if it is in motion. What definition says? Wave associated with any object when it is in motion. Such waves are the matter waves. How? If we think or we take example of electron beam. If a beam of electron can be diffracted, it diffracted just like a beam of light, is the example of the matter wave. Now in this chapter some eliminated part, that is the reduced syllabus part, is the common properties of the wave, such as amplitude, wave, period, double periodicity, frequency, velocity, characteristic of progressive wave, transverse wave, longitudinal waves. These are the reduced part in this chapter. Though this is reduced, but when we want to study the sound and waves, we must know these basic properties of the wave. Amplitude. First is the amplitude. What is amplitude? Amplitude is a largest displacement of the particle from the mean position. Amplitude of wave motion is largest displacement of the particle of medium through which wave propagated from its rest position. Maximum displacement of the particle from the mean position is the amplitude. Okay, and it is measured in meters, and symbol given for that is capital A. This is the amplitude. Wavelength. Wavelength is the distance between two successive particles, but that particle must be in same state of vibration. How one can define? It is the distance between two particles, distance between two successive particles which are in the same state of vibration. This distance is called as wavelength, and it's also measured in meter. Okay, this is the second property. Now third property, period. Time required to complete one vibration by the particle of the medium is called its period. Time required to complete one vibration is the period, and it is measured in second. Doubly periodicity. Doubly periodicity. Doubly word means two. So which two are involved in this definition? That is periodic in time and periodic in space. What is by periodic in time? If wave motion repeats itself at equal interval of time. If wave motion repeat itself at equal interval of time, this is called as periodic in time. What is by periodic in space? If form of wave repeats at equal distance, that is called as the periodic in space. And if the waveform is periodic in time and periodic in space, that means it has a doubly periodicity. Doubly periodic waveform. Okay, this is a doubly periodicity. Frequency. It is the number of vibrations performed by the particle during each second. In 1 second, how much vibrations are performed by the particle is called as the frequency of that particle, and it is presented in hertz, or its SI unit is hertz. And another one term is given, that is the period. How frequency is related to the period? Reciprocal of time period T is the frequency, or frequency is the reciprocal of periodic time. Okay. 6. Property, velocity. Distance covered by the particle or a wave per unit time. Distance covered per unit time. Distance covered per unit time is called as the velocity, because common definition of velocity is distance upon time. But we must know, if we want to find out magnitude of the velocity, we must know the how it can be relate with frequency and the wavelength. This is basic equation. So that can be derived as magnitude of velocity is equal to the distance upon time, basic definition of velocity. But in one period, that wave cover the distance which is equal to wavelength. Hence, distance can be replaced by the wavelength divided by its period. So, what we get? Velocity v is equal to lambda upon t. Lambda is the wavelength, which is the distance covered in time t, that is one period. But we have equation for frequency, that is the frequency is the reciprocal of period. Okay. Now, replace this period by n is equal to 1 upon t, then we get the equation v is equal to n lambda, which is the relation between velocity, frequency and the wavelength. Okay, these are the basic points we must know while studying the sound chapter. Okay. Now, progressive characteristic of progressive wave. There are two characteristics of progressive wave. When wave travel through the medium, but what is the progressive wave? First upon we must know what is the progressive wave. Wave in which disturbance created one place travels to the distant point and keep traveling until stopped by some external agency. That means it moves in a given direction continuously, hence progressively, hence it is called as the progressive wave. What are the characteristics? There are two characteristics of progressive wave, that is the vibrating particles of medium have same amplitude, same period and same frequency. This is the first property. Second property is the state of oscillation, that is the phase changes from particle to particle. Okay. What is my phase? Another word is here phase. What is my phase? State of oscillation of the particle is called as the phase. Okay, it can be different for in progressive wave, it is different for particle to particle, it varies particle to particle. These are the some important point. Now we are going to the two types of waves, that are the transverse wave and longitudinal wave. Transverse wave, wave in which particles of the medium vibrates in a direction perpendicular to the direction of the, this is the direction of the motion of the wave. Okay. If vibrations of the particle are perpendicular to the direction of the wave, such a wave is called as the transverse wave. Particles of the medium vibrates perpendicular to the direction of the propagation of wave. This is called as the transverse wave. Okay. This is the direction and this is the direction of propagation of wave. These two are direction of vibration of particle. These two are perpendicular to each other. Such a wave is called as a transverse wave. Okay. Now, we are going towards the longitudinal wave, in which particle of the medium vibrate in direction parallel to the direction of propagation of wave. Okay. In transverse wave, that wave divides medium into alternate crest and trough, whereas longitudinal wave are the in which particle of medium vibrates parallel to the direction of propagation of wave. Okay. How this, when this longitudinal wave travels to the medium, it can be divided into alternate crest and trough. Now we are drawing that. Okay, this is compression, this is rarefaction, compression, rarefaction. these particles vibrate parallel to the direction of propagation. Okay. Such a wave is called as the longitudinal wave. Now, we are going toward the next point, that is the mathematical expression of the wave, progressive wave. Progressive wave, it can be represented by two functions, that is the position x and time t. These two are necessary for the presenting the progressive wave. So, here position can be expressed by x position can be expressed by x and t, time t. Okay. These are two needed functions for the presentation of the progressive wave. Why these are essential? These two functions will describe the shape of wave at any instant of time. These two functions describe the shape of the progressive wave at any instant of time. Okay. Hence, these are the required functions. Now, sinusoidal, we have to consider sinusoidal progressive wave described by the sinusoidal function. Let us assume a progressive wave is transverse. Progressive wave can be divided into two types, that are the transverse wave and longitudinal wave. We have to consider the transverse wave for this expression. Okay. Position of the particle of medium is described by fixed value x. Okay. Then displacement from the equilibrium position can be displaced by the displacement of the particle from its equilibrium position can be given by this symbol y. Okay. So, this first equation gives the sinusoidal waveform for the progressive wave. Here the symbol a, k, omega t and phi are the constants. Constant, these are the constants. Okay. At a particular instant of time t0, at the particular instant of time t0, how we can write the waveform? A sin kx omega t plus phi minus omega t plus phi. Now, this becomes a sin kx plus constant. Thus, the shape of wave at t is equal to t0. Now, this decide, as we say, this x and t decide the shape of the wave. This shape of the wave at t is equal to t0 as a function of x is a sine wave. This is the function of sine wave. Okay. Also, for the fixed value of x is equal to x0, for x is equal to x0, x is equal to x0, we have to write the equation. Now, in this equation y is equal to x0 t, the equation is written as a sin kx 0 minus omega t plus phi. Okay. Again, this k, omega and t are k x0 phi are constant, and this function can be written as a sin constant minus omega t. Okay. Hence, the displacement y is at x is equal to x0 varies as a sine function, as a sine function. Okay. This is sinusoidal waveform. Now, this equation number 1, representing a wave traveling along positive x direction, Okay. Y is equal to Now we are going to y is equal to x t is a displacement function. Okay. Now we have to this written equation is equation of the wave when it travels in negative x direction. Okay. Here we have minus omega, here plus omega, this is plus x direction and this is the minus x direction. Okay, these two equations are in opposite direction along. In this equation number 2, what is A? A is the amplitude of wave, K is the angular wave number, omega is the angular frequency of the wave. Here the bracket, which bracket? This kx omega t plus phi is the argument for the sinusoidal wave, and this gives the phase of particle at t and x. Okay, this is the equation for the mathematical expression for the progressive wave along positive x direction and negative x direction. Okay, thank you.